Hello everyone, welcome back to Brain Power classes. This is our part 2 of class 11 geography. So, we have already learned about erosion, process of erosion. Now we will be moving with the agents of erosion, second major agent that is work of sea waves. So, let's continue with the remaining agents. First, we will be going to learn about sea waves. After that, wind, groundwater, and glaciers. As always, we will understand every concept in simple language exactly according to the textbook. So, first is work of sea waves. Just like rivers, sea waves also erode rocks. The most effective process of erosion by sea waves is absorption. Sorry, abrasion. So remember, abrasion means the rock particles carried by waves rub against the coastal rocks and wear them away. Sea waves can also cause chemical erosion through solution. Along coastal areas, salt weathering is also important. So sea waves can also cause chemical erosion through solution. Along coastal areas, salt weathering is also important. I have repeated now. So, what things are formed here? First, it's sea cliff. When waves continuously strike a steep, rocky coast, the rocks start breaking, and this erosion creates a steep wall along the coast called a sea cliff. So the softer rocks are generally eroded first. Next, sea cave. Suppose there is a softer portion in the coastal rock. Waves continuously attack this weak portion and make it hollow. So this hollow is called a sea cave. Third part is sea arc. When waves continue to erode the softer rock, the opening may become larger and pass through the handline. So this creates a sea arc. As sea arc can also form when two caves from opposite sides of a headland meet. Next is sea stack. If the roof of the sea arc collapse, a separate column of rock remains standing in the sea. This is called a sea stack. Next is wave cut platform. The surface at the base of a sea cliff is called a wave cut platform. It develops mainly because of abrasion. These platforms can be clearly seen during low tide, and they also provide evidence that the sea cliff is gradually retreating. Now, what are the depositional landforms of sea waves? So, now let's understand deposition by sea waves. The most common depositional landform along a coast is beach. So, beach, a headland is a portion of a land that projects into the sea. Between two nearby handlands, the coast is generally concave. So the eroded material brought by waves gets deposited there, and rivers and other agents also bring sediments. So since the water is shallow, wave velocity decreases and sediments are deposited. These sandy deposits along the coast are called beaches. Examples in you can see in Maharashtra include Divyagar, Guhegar, and Hareshwar. Marine Beach in Chennai is the longest beach in India. Next is sandbar. So sand can also accumulate along the sides of headlands. Over time, these deposits extend parallel to the coast and form a long ridge of sand projecting into the sea. This is called the sandbar. And in Maharashtra, sandbars can be seen at Srivardhan at Revadanda, Srivardhan and Revdanda. So the sandbars offer the first protection against the storm or tsunami by absorbing most of their destructive force. Now, lagoons. Sandbars can provide protection against storms and tsunami waves. Sometimes the area between the sandbar and mainland becomes enclosed. The water trapped there is brackish, meaning it contains more salt than fresh water. So, such a water body is called lagoon. So, examples are Chilka Lake in Odisha and Vembanad Lake in Kerala. So, during monsoon, Chilka Lake becomes a freshwater lagoon. Next is sand spit. Sometimes the sandbar remains connected to the mainland and extends into the sea. Such a depositional feature is called a sandpit. So, next is uniqueness of a coastal areas. So, coastal areas are different because the work of sea waves continues almost continuously. Erosion and deposition keep occurring side by side. Even beaches and bars, which are depositional features, can later be eroded. Coastal areas are also vulnerable to sea level rise and submergence. So, and because population density is high in many coastal regions, coastal zone management is very important. So next one is work of winds. So let's come to the second agent. Sorry, it's a third agent, work of winds. So globally, wind is less effective than rivers, waves, groundwater, or glaciers. So, but in desert regions, wind becomes a very important agent of erosion. What are the conditions required for effective wind erosion? There are four main conditions important for this. First is aridity. Evaporation is greater than precipitation. Sparse or no vegetation should be there. Dry, loose material on the surface. High wind velocity capable of moving sediments. These four are important. Next is deflation. When strong wind blows over loose sediment, it picks up and removes small particles. This process is called the deflation. Deflation can create shallow depressions called deflation hollows. A famous example is the Qatar Depression in Egypt. It is about 300 km long and 135 km wide, and its deepest part is about 133-meter below sea level. So this is about deflation. Next is windy facts. Venti facts. So when the wind carries sand particles, they strike and polish exposed rocks. This process is called the abrasion. You can see the ventifex in figure 3.3a. So the windward side of the rock becomes smooth and sloping. Such wind polished rocks are called ventifex. Next is mushroom rock. Figure 3.3b shows mushroom rock. Wind abrasion can also create mushroom rocks. Why does this happen? So the sand carried by wind attacks the lower and middle portions of the rock more strongly. So the upper portion is comparatively less eroded. Therefore, the middle portion becomes narrow and the upper portion remains broad. The rock gets a mushroom-like shape. That's why it is called as a mushroom rock. Next, Yardang. When hard and soft rocks occur together, the soft rocks are eroded faster. The harder portion remains elevated. The remaining elongated ridge is called a Yardang. Figure 3.3 C shows Yardang images. Now, attrition reduces the size of the particles as the dash against other mutual bouncing. Now, what is wind transportation and deposition? Wind transports materials mainly through traction and saltation. Larger particles move near the ground while finer particles can travel higher and further. When wind loses its carrying capacity, it deposits the material. Coarser materials form sand dunes. Fine particles like silt can travel hundreds or even thousands of kilometers. These deposits are called loess. Now, what are the types of sand dunes? First is Barchans. So, Barchans are crescent shaped sand dunes. They form where the supply of sand is limited. The slope pacing the wind is gentle while The opposite slope is steep. So large number of branches can be seen in the Great Indian Desert of Rajasthan. Next is longitudinal dunes. Longitudinal dunes are long, narrow dunes that extend parallel to the direction of wind. So they are also called seaf dunes. They may extend for hundreds of kilometers. They can be seen in Rub al Khali Desert of Saudi Arabia. Lewis deposits. Fine wind blown sediment can travel very long distance and get deposited far away from deserts. These deposits form loess plains. For example, northern China has thick loess deposits brought by winds from the Gobi Desert. These plains are very fertile. Now, working of a groundwater. Now let's understand groundwater. Just like water flowing on the surface, underground water also moves and changes the landscape. Rainwater and melted snow enter the ground where the bedrock is soluble, especially limestone. Groundwater becomes an important agent of erosion. You can see in figure 3.4a, it shows a work of a groundwater and different particles formed in it. First, we will learn about karst topography. So, groundwater can dissolve, remove, transport, and deposit rock material. Limestone is particularly important because it is made mainly of calcium carbonate CaCO3. So, landforms created by groundwater in limestone regions are called karst landforms. The terms comes from the karst region of the Dalmatian coast of Croatia. In India, karst features are found in parts of Meghalaya, Boro caves in Andhra Pradesh, Kannur Plateau in Maharashtra, Madhya Pradesh, and Chhattisgarh. Now, what are the conditions? Conditions for karst topography. Karst topography needs three important factors to develop. First is carbon dioxide. Carbon dioxide makes groundwater acidic and helps it dissolve limestone. Second is active groundwater movement. Groundwater contains Groundwater containing dissolved carbon dioxide must be able to move throughout the rocks. Greater permeability means easier movement of groundwater. Third is joints. Joints and fractures in blocks provide pathways for water to enter and move through the rock. Next is erosional and depositional landforms. So, in that, now because of erosion and depositional landforms, sinkholes are formed, caves are formed, stalactite and stalagmites are formed. So that we are going to learn now. So first is sinkholes. So groundwater enters cracks and joints in soluble rocks such as limestone and gypsum. Acidic water dissolves the rock. The cracks gradually becomes larger. Eventually, roughly circular depressions develop on the surface. These are called sinkholes. So sometimes surface streams also disappear underground through sinkholes. Sudden collapse of a sinkhole can become a natural hazard too. Next is caves are also formed. Groundwater can continue dissolving rocks and create underground passageways. So when water reaches an impermeable rock layer, it may flow sideways. So over a long period, this process can create caves. Some caves can be several kilometers long. For example, one cave in Meghalaya is about 23-kilometer long. Next is stalactite and stalagmite. Now, remember, this is very careful. This is careful. Remember this very carefully because it is very important for exams. So, water containing calcium carbonate drips from the ceiling of a cave, and the deposits growing downward from the ceilings are called stalactites. The deposits growing upward from the floor are called stalagmites. If they continue growing, They may meet and form columns or pillars. So, just one important and easy trick to remember stalactite and stalagmite. Stalactite is ceiling, stalagmite is ground. Now we will be moving to next agent is work of glacier. So finally let's understand the work of glaciers. Glaciers are important agents of erosion. Erosion in high altitude regions beyond the snow line and in polar areas. So in high altitudes and high latitudes and high altitudes, precipitation mainly occurs as snowfall. Snow accumulates layer upon layer and changes into ice. Due to tremendous pressure, the ice slowly moves down the slope. This moving mass of ice is called a glacier. So, erosion by glacier. Glacier performs erosion, transportation, and deposition. They erode rocks mainly through two processes. First is plucking, and second is abrasion. So, plucking removes pieces of rock from the bed. Abrasion occurs when the material carried by the glacier scratches and wears the bedrock. Now, Roche Mountoni, the concept here given you can see here. So, plucking and abrasion at the base of a glacier can produce a landform called Roche Mountoni. So it is a bedrock hill that becomes smoothly rounded on one side due to abrasion while plucking acts on the other side. So in this circuit, horn, U-shaped valley, hanging valley, these all are formed in this. So that from here we will be moving. Huh. So, ice movement accompanied by weathering and mass wasting steepens the wall at the head of the glacier. It deepens into armchair shaped depression called cirque. So, due to ice movement, weathering, and mass wasting, the head of glacier becomes deeper and deeper. It forms a armchair shaped depression called a cirque. Next is arid. When two or more circuits develop side by side, the narrow ridge left between them is called the arid. Is called an arid. Next is horn. When three or more circuits develop around a mountain summit, erosion can produce a sharp pointed peak called a horn. Next, in this, the Matterhorn in the Swiss Alps is an example of it. As the glacier moves ahead, they erode the side as well as the bottom of the valleys. They flow through lateral and vertical erosion equally. Now this makes U-shaped valley. Now we are going to learn about U-shaped valley. As a glacier moves through a valley, it erodes both the sides and the bottom. This makes the valley broader and steeper. So this is the result. The result is a U-shaped valley. Remember, river V-shaped valley, glacier U-shaped valley. So now in this, hanging valley is also there. So glaciers can also have tributaries. The main glacier erodes its valley faster than the smaller tributary glaciers. Therefore, tributary valleys remain at a higher level compared to the main valley. These are called hanging valleys. After the glacier disappears, waterfalls may develop where hanging valleys meet the main valley. Now, depositional landforms of glacier. First is drumlin. Coarse material carried by glaciers gets deposited as heaps. These heaps have an egg-like shape and are called drumlins. When many drumlins occur together, they look like a basket full of eggs when viewed from above. Next is iskers. Now, when coarse material is deposited in a long linear and zigzag pattern, it forms a iskar. Next is erratic rock. Sometimes huge rocks are transported by glaciers and deposited in an area where the local rocks are completely different. So these foreign looking rocks are called erratic rocks. You can think of them as a guest rock in the in that area. Next, so these were three landforms formed by them. Others can be moraine also in that. And in moraines, glaciers also deposit sediments along their sides and at the fronts, and in that, so these deposits are called moraines, and in that, lateral moraine, end moraine, terminal moraine, medial moraine, these are three. So what are lateral moraine? Deposits alongside of a glacier are called lateral moraines. End moraine, deposit at the toe or front of a glacier form an end moraine. Terminal moraine, the end moraine marking the farthest advance of the glacier is called terminal moraine. So medial moraine is the last one. When two tributary glaciers join their lateral moraines, merge and form a medial moraine. So you can see here pre-glaciation figure 3.1, 3.5 depicts 3.5b depicts 5b depicts during glaciation, and figure 3.5c post glaciers. So here we are done with the chapter. So let's revise the four agents we studied today: sea waves, sea cliff, cave, arc, stack, beach, sandbar, lagoon, and spit. Wind, deflation, hollow, ventifact, mushroom rock, yardang, and sand dunes, and Lewis. Groundwater, karst topography, sinkholes, caves, stalactite and stalagmite. Glacier, rock mountain, cirque, arid, horn, U-shaped valley, hanging valley, drumlin, issue, erratic rock, and moraine. So, and this with this, our chapter Agents of Erosion is complete. So, keep learning, keep revising, and I will see you in the next chapter.